Okay, and welcome everybody. So in this video, I am just showing you images of a sandbox. So it's a very simple way to visualize essentially an aquifer or underground water. And here's the video. Let's see. Yeah, we can pause it here. So in this first sequence, you can see I only have an inflow, but no outflow. So obviously the water is just going to accumulate in the sandbox with a water table that will be horizontal essentially. So you can see here I have a lake on the right hand side and a alluvial, or this is like pea gravel size alluvium. So the water goes into the ground, fills an aquifer, and then exits right here. You can see the outflow from the underground into the lake. Okay, let's see the side view here, and here it is. So you can see that the water is accumulating. Obviously, if there's no outflow, it's just raising. One other interesting thing is it's a little bit subtle, so it's not very obvious in this video, but you can see here where the wetting front is, so that would be the water table underground. You can see that it's rising a little by capillarity. It's a little higher than the level of the lake. So it's not just like a straight shot, but there's definitely a wetting front above that water table here. Okay, so you can see it, fill up, and now it's gone. Okay, so in that second experience or experiment, or in that second, sequence, now I'm adding an outflow, right? So now we have inflow on the left here, and then outflow on the right, like it would be, with a real system where there's basically a head gradient. So there's, inflow and outflow. Okay, let's take a look at this. And I'm sorry, this is a little bit shaky, some of it. I tried to do a better job later on. I have a tripod, and here it is. So this is just to illustrate. So you can see when I add the rhodamine. So rhodamine is just a dye, that red dye here, right here, right? So I'm adding color, if you want, a dye, so that we can see the underground flow lines or the underground flow, and you can see how this is disappearing into the ground and then finally reappearing somewhere downstream where the aquifer comes out of the ground, so where the groundwater seeps. Now here's a side view, and you can see here we have the aquifer. Now the sand is a little bit wet, so it's not as clear, but we'll see in a second. I'll reset the experiment and you can see it. But here from the side view, if you have, let's say, a spill or water starting here, you can really visually see how it flows parallel to the ground underground here. So again, just to visualize a little bit the transport. And again, the whole system. So here I'm just moving the inflow closer to the boundary so we can see the flushing a little better. And now you can really see where the water inflow is here, and then it's flushing all that water, obviously, downstream, into that lake. Notice here how this part, here it is. So here's a better view of that. So here we're filling it up. This is dry ground, if you will, right? So there's dry ground, and here's a spill, let's say, an underground container in the ground, but not in the aquifer, spilling into the aquifer. So now we can really see that wetting front here in the aquifer. And then you can see how basically this contamination, or the red dye, is not really being flushed through the aquifer, or that is, the aquifer, the water actually flushes out the red, but because the red is in the dry soil, if you will, or the soil that is not saturated, not the aquifer, you can see here how it accumulates, it stays basically in the ground, and then sort of, hangs on to that water table, to that wetting front, but that isn't really getting flushed because it's basically absorbing to the matrix, right? So it's not being flushed as well as if it was underground. And here you can see it, another illustration of this, right? Same thing. You can see here we still have that dry lens, and here's another example when we add it, at the top of the aquifer, right, versus inside the aquifer. And let me show this again because this is quite good. So if we add it at the top of the aquifer here, you can see how it spreads, at the interface between the saturated aquifer and the unsaturated vadose zone, or soil here. And again, all those definitions we'll see in in the remaining videos, but you can see how this accumulated at the top. Here, this very last one that I did is very different. You can see when we add it inside the aquifer right here, so we're inside that saturated, water zone. So when we do this, you can really see here it was on the top, and now it's on the bottom, and you can even see these almost circular flow path underground. So here, let me just go back a little bit. Again, the top one here on the top, and then the bottom one here. Look at those flow lines, see, going down and back up. So really going down and back up. There's that circular motion, really that circular flushing. Those flow lines are, following the topography or following those, down and up motion. Okay, so hopefully this was just to illustrate the different parts of the underground water and a little bit of the behavior. Thank you very much. Bye.